Hello everyone, and I have a CSS exploration for you. I built this a little while ago and I wanted to share it. It kind of explain how I built it, what went into it, what's needed. I use sibling index and sibling count, CSS Trigonometry, and one class name, and about 100 lines of CSS. And so the deal was I wanted a kind of curved component and I wanted it to work no matter how many cards we throw into this component. And the one class name is on the wrapper, and so all we're doing with this right here is changing the number of divs inside this container, and they get arranged perfectly. And then I also wanted to be somewhat responsive, although this is more of a lateral kind of layout. So we are able to adjust styling based on the size of the container as well. So it gets real technical. I'm going to try to be concise as I explain it, but there's a lot of moving parts to this as I figured out the math needed to get this arrangement to be derived. And of course, I'm wearing the torque.dev hat. I just got it the other day, and I'm a Torque ambassador. They're a tech hiring business, but there's a Discord community that's very vibrant, full of lots of friendly people that are very um, supportive, especially as someone who is looking to transition into tech and learning and growing. It's a nice place to be, very encouraging. So I can't recommend it enough. That being said, let's get into the CSS. The one class name we have is on our wrapper. And I wrote this to be as flexible, as open-ended as possible, with the idea that, let's say this was a real component, someone could just put that class name onto a wrapper and the children would then be styled like this. It would just work. And they could have whatever sort of styling they wanted on the individual children, except, of course, some positioning things. Um, but they could look and be whatever a person wanted, but get this sort of radial layout. This was inspired from the Lando Norris website. Syntax did a review on it, and that kind of gave me the idea of, can I do this with pure CSS? And no libraries. And so that was the goal here. So the way this works is the cards are positioned with trigonometry, and I'm using sibling count and sibling index. And I need those to know how many cards we have, to know how to arrange them evenly without hard coding anything. And so that's how they get used. But first, I want to talk about all the way at the bottom here the trigonometry that I'm using to place these cards, the transform. So we have a cosine. Pretty much we're translating along the x-axis, and we have our comma, and then the y-axis, right? That's how a translate can work. And so the cosine of an angle times my radius. And so this could be hard numbers. And you can set hard numbers on cards with this, and you get your, for whatever the radius would describe kind of the size of a circle, right? And whatever that size circle is, from a central point, if you were to calculate the angle and the radius, you can plot points around that circle, right? And so I make these cards position absolute, and it's in a flex box, and so they all drop down into a central point. And from that 0 point, I'm able to calculate our radius. So now I move them up to the edge of that circle. Now you say, well, if it's at the center of this container and you move it up, how, what's happening? I also have this top calculation here. And what I'm doing in this is taking a lot of the different variables that I have, the different card heights, the different, the different card heights, the difference of that card height, the container size, and then I'm subtracting all that to bring it down to dead center on that container. And so I'm moving it down first and then transforming it back up, and we end up centering a div in a really complicated way, right? So trigonometry, cosine, we're plotting like a triangle essentially, and we're figuring out how far out we need to go. And then the sine of the angle times our vertical radius tells us how far up. So then we can then track each position around a circle, right? And so right now, what I have set for our radius is 1,000 pixels on each of these. So and then also the reason they are just arranged within that spread right there is our arc spread value. So I can change this and expand, how big of a circle, how big of a part of the circle we're going on. We could do a full circle, of course, if we don't limit it in our calculations. So I'm using this variable to determine how far apart the cards spread along this 1,000-pixel circle. So imagine a 1,000-pixel circle, and we're just taking a section of it to spread these cards out. And of course, these radii can be changed. And if I decrease both of them, they don't have to be the same. We can make this one 1,000, and that changes how far out the cards spread. And this determines how tall of a radius our vertical one is. And so what I end up finding is the larger radius and an even radius makes for kind of more symmetrical arrangement. But we can, get crazy with this and keep changing it. And of course now a 2,500 radius vertical radius and a 1,000 pixel horizontal, you have this oblong shape, and we can kind of see the cards traversing along that path. So that's how I like to reason along the transforms and these radiuses, is to imagine a circle and the transform is moving from the central point to where that circle is plotted. And if we change the vertical radius, we get a flattened circle. If we change the horizontal radius, we're adjusting the size of our circle, right? Does that all make sense? That's how the trigonometry works. That's how the placement works. And so we can use that principle in a lot of different ways in order to determine the relationship of one card to a next. We could use this even for things like hexagons or like a honeycomb kind of layout, because that relationship is also going to be a set degree and a set distance based on your height and your width, right? So trigonometry can be used in a lot of different ways for these layouts, and understanding kind of what we're doing with those transforms can help a lot. All right, now, so we have our sibling count and our sibling index. Those let us know how many cards are in the container, right? And then we know which card is which. So between those two, then we can take our other variables and derive where they need to land in order to get this symmetrical, even layout. So I have the vertical radius, we went over that, the horizontal. We have our card depth, and what I'm doing is I have a set value by how much these cards should step down as we go towards the edges. You see how they shrink a little bit and they're a little bit smaller, kind of almost like they're getting further away a little bit. We could probably do some z-index, rotation on this. We could do a lot. We can do anything. Let's not worry about that. I'm also calculating how far from center the cards are. So right now, our center card is flat, it's dead top, and everything else is arrayed around that. Now this is not the first card in the DOM. If we inspect it and look at these, it's the first card is all the way to the left. So that's something to consider, I think, going forward. If I were to go forward with this, is odds are someone building a website and using this sort of thing would want the first one to be dead center. I think this would excel in a layout where it doesn't really matter that much, but that might be something to think about. But I'm calculating how far from center each card is, and what this ends up doing is we get some negative numbers on this side, and we get positive numbers here, and it's like 0.5, 1, 1.5, and so we get this equalized distance from center that can then be used to calculate a bunch of different things for each card. As they get further from the center, they get smaller, like with our card depth. As they get further from center, our rotations change, our offset angle changes, all that sort of thing. We have our height as a custom variable, and I clamped that because I have the height based off of the container height, right? So no matter, it's responsive to the container that these cards are placed in. That might not be a necessary factor. We could leave that to the user to determine card height and size, but that would actually break the layout. So no, we have to control that. So scale from center height. I then, this is where we start getting a little crazy. we're taking our height, we're doing absolute, so we only have positive numbers for the cards from center, and then we're multiplying it by our card depth value. So whatever this happens to be in the clamp, because the height's changing based off container size, if it was in really small heights, this card was getting teeny tiny. So I had to step it down to only being a 10 pixel reduction all the way down, to make it a little bit better than the 4 container query height units. And so, and then also on the high end, we had to do an absolute value so that the 4 container query height units wasn't too much of a step down. You know, that's what clamp is good for. So height, absolute value of the cards from center times our card's depth. And so then we get this shrunk height going all towards the edge. And then we set the actual height property to the scale from center height. And so this is based off of our sibling index is helping us determine all of that. Actually, sibling count. The total siblings is what's needed for that. I had to figure out the height difference in a variable to help with the math on the top calculation. So what I'm doing is I'm figuring out this card, how much smaller it is from this card, so that when we position them with top, normally the smooth edge of the curve would be the top upper edge of the cards, because everything's placed, you know, it goes as far up in the DOM as it can be unless you move it down, right? And so that was happening with the transform, but I wanted the bottom edge to be smoother. It felt more like a normal hand of cards that someone would be holding, kind of what this resembles. And so we had to figure out a height difference, and then that gets used, I should reorder this, that gets used in our top calculation. We had to figure out that we had to plug in the vertical radius, we had to figure out the container query minus our height plus the height difference divided by 2, and calculate all of that to get them all to evenly arrange in the middle of this container. That's where the container query units come from too. Okay, so a lot going on there, right? Let's come back up. That was our height difference. Our aspect ratio, I use that. I might want to change this. Right now, the width is based off the height, but I think the more critical factor in this sort of layout is the width, and I think rather than the height. So I don't know. That probably should change. Now our offset angle is, we're taking our arc spread variable. Remember, I set that to 60 degrees, so we can determine whatever that needs to be. And then we're dividing it by our total siblings. So that's how many cards we have. 60 degrees divided by the number of cards gives you how many degrees each card needs to be spaced to fill that gap, right? And so then we multiply it by 1 degree to coerce it into that angle type that CSS needs. Make things a little bit easier with the math. Now, using that offset angle, we know how much of a spread we need. We know how far from the center each card is, and so we can take our 270 degrees is dead top 0, right? In trigonometry and CSS, that's not always the case with other. It's 0 degrees in gradients. You know, it's dead top center, so it's a little confusing getting in this. But we take our cards from center, multiply it by that offset angle, so that each card is the same arrangement as it goes out from the center. And then we add the 270 degrees to normalize it up to this, you know, vertical hand positioning. Because if we get rid of this 270, it's going to be off to the side. We have overflow. We're way over here. There. So that's our center point on our circle. And we have our arrangement. And the rotates are all set for 270 degrees. So, yeah, that's how that is working. Let's bring that back. There we go. We're back in action. So obviously this is very fragile. You change one thing and some things can break. It's pretty solid otherwise, but yeah. Okay, so we figure out our angle with all of these derived positions. We have our layer is our card from center subtracted from total siblings. That number, doesn't really matter what the number is, but this just gives us a unified, each set of cards from center stacks behind, the others. And then we set the z-index to that layer. So we get this stacking. And then when I hover, I just set a very large z-index to override that. We have our top value, we went over that, and our transform. Okay. So that's the main functionality of this. Then we have our hover states, right? Because right now you notice the two cards to the right of the hover card and the two cards to the left of the hover card are changing styles as well. Now right now I left them rather subtle. It's not, excessive. That can be changed and we can kind of do whatever we want. I think I would like to change it to be a animation rather than just adjusting the transform like I am here. So right now on the hover, we just take our transform and all I'm doing is changing the vertical position by subtracting a set number of pixels, right? And so there it jumps up because of that subtraction. And we can control that to be whatever we want, not 1560, but let's say 150. It really jumps up, and then, that gets a little bit glitchy. That's why I think an animation would be better. With the hover, it might run a bit smoother, and then you have more control of keyframes and bouncing things and making it look a little bit more delightful. So we have our hover state, and then using nesting, I'm selecting the next sibling here. And I'm using these star selectors to make this more flexible. Some opinions probably would be ideal here. Probably should be a div or whatever, or a specific class name on the children. But I wanted to make this just more plug and play, and so I did it that way, and it's not terrible for performance. It's just CSS. Our computers are fast enough to handle a few any selectors. So what that does is now we're selecting the next sibling of whatever's hovered, and we're applying a different transform to it. And again, we could set a different animation for that, and I think that would be ideal. And then I'm nesting again, so any child that's transformed, and now any sibling of something that's hovered, and then the next sibling. So that gets us the next two. And of course, you could go 3, 4, you could go however many levels deep and adjust the styles for those as well. Something that I think might benefit these is if we know distance from center, and we know, like, we could calculate also how far from the edge they are, and so we could set specific styles for these depending on where they are in the arrangement. Oh, I want them when they're this close to the edge to just move this far. I want them when they're this close to the edge to, go here, there, like the ones on the far edge, I don't want them moving them outside because they'd go off screen. I want them coming in, or I want them just going up, or, there's so much control that we have here. As long as we got the selector, we can do anything with these. And then we know where it is in the position, where it is in the arrangement, and so yeah, any you can write a calc to manage all that. Now to get the ones to the card to the left, higher up in the DOM, we have to use has. That's the special sauce here. So right now we're saying card component, we're selecting the star, anything in here. So any card in here that has a sibling that's being hovered. That's how this selector reads. So we've got this one is being covered. I'm pointing at my screen like you can see what I'm pointing at. But the card being hovered next to it to the left of it is what's being selected with this selector, right? And then we can't nest it just because of, we probably could nest it, but I didn't want to. I didn't think it was very readable. Now we're doing it to siblings. So card component, any child that has a previous sibling or a sibling and a sibling that's being hovered. We're going 2 steps over. So if the card 2 steps over down is being covered, let's style this guy, and that's what we're doing. And of course we're changing the translate, the transform, and adjusting it, the values on it to control that. Again, should be an animation. It's being repeated here. Should be a custom property, so you change it in one spot. Everything else is equal and even, and that would all work. So that's how the hover states work. So you can do a lot with has. Has is amazing. So if that gives you an idea for something where you want to hover siblings or move siblings based on the hover state of the one right there, like in a nav. Let's say you have a nav menu and you have a fancy little glow box shadow effect or something on the hovered one, and you want the previous and the next one to kind of sympathize or react to that. That's how you do it. All right, now our container queries, because I made this container, we can use container queries to adjust the styling, like I was showing, based off how much room we have. Now, of course, if we have a narrow width, I don't think anyone should ever do this kind of component in something so small. Or, we make the cards very small to fit, or, whatever the case may be. Maybe we have more height. These container queries let us go in, change whatever styles, whatever variables we need, and then everything is still derived accordingly. So let's say we go real small. Oh, look at that. So, um, you know, the container query makes this a lot more modular and flexible. That's where a user could come in and control the styles based off of the viewports that they're hoping to work on. Yeah, yeah, that's the whole thing. So if you have any questions, complaints, criticisms, I'm open to all of it. This might have been the dumbest idea ever, and you can tell me that, and that's okay. I don't. This was an exploration and an experiment. I don't expect it to be anything more than that, but it was fun to see if it was possible, and it is. I think libraries are probably the better way to go. It's a little bit more maintainable, more realistic. Using a little bit of JavaScript in this, it doesn't really hurt anything. But I do like that CSS is moving in the direction that JavaScript isn't really needed. And I think there's a lot of ways that the web actually gets hurt by JavaScript being used for styling. You get these layout shifts, you get non-accessible kind of layouts and this blocking that can happen for styling when CSS can just do that for you for free. So that's kind of my thoughts on that. I guess not a hot take. Yeah, I don't think that's even a warm take. I think that's just the way the web should be. But it's fun. So if this gave you any ideas, I'd love to hear about them. I kind of want to see if I can just plug this into a stylable select list and then turn a select list into this sort of radially arranged thing. Can you imagine you open up a select list and you've got just this array of options before you? I think that could be kind of fun. Um, Maybe impractical, but kind of neat. I mean, think about it. I feel like there's some old Star Wars games where it's like a hologram projector and you have the different options set up, and then your hover state makes them glow brighter or something like that. I mean, that'd be kind of a cool select list to have. So I mean, the sky's the limit. You can really do anything. It's just a shame I'm not much of a designer. All right, I've yapped for a long time. I hope that made sense and maybe gave you some insights on how to do it. I will post the GitHub repository if you want to play with the code and mess around with it on your own. Yeah, reach out if you have any questions, thoughts, comments. Torque.dev, great Discord community. If you want to hang out there, I'm in there all the time. And I hope you're having a wonderful day. Catch you later.